Here we are, section 6.3, naming ionic compounds. When we're all done with this video, make sure you watch video problems 20 and 21. Alright, so now we talked about, hey, these things get together, they form ionic compounds, and a compound is neutral. Now we're going to talk about naming those compounds. Pretty easy for the simple ionic compounds. It's just simply, you say the name of the metal, right? And then you say the name of the nonmetal. And the nonmetal, remember, ends in IDE. Here's a couple examples. Let me do these up here. Here's Ki. Right? You say the name of K, which is potassium. You should have that memorized. And then you say the name of I. That is iodide. IDE. It is not iodine because it's an ion. So when we say you have an iodide, we are talking very specifically about the ion. So here, let's try this one. MgBr2 as an example. So there's a 2. Do we do something different? No, we do not. We call this magnesium bromide. Alright. So that's for simple ionic compounds. Now, there are some transition metals. Let me remind you what a transition metal is. So here are the transition metals. Right, so all the way through here, the transition metals. I've seen a couple sites lately that are calling this group the post-transition metals. I don't know if that's a new thing that they're coming out with, but just be aware that that's out there too. But all in yellow there, those are the transition metals. Some of those transition metals, not all of them, just some of them, have more than one charge. And that's a problem. Here, take a look. Here, iron 2 and iron 3 here, alright? So here is iron, right? Here's Fe 2 plus, has a charge of 2 plus. Let's combine it with oxygen, right? So that formula is FeO, right? Now let's look at the other iron. Here's iron 3 plus. Here's O2 minus. Now when these combine, I'm going to be Fe2O3, and we'll get into that in a little bit. But what would you call this? Well, this one, according to our naming rules so far, is called iron oxide. And this one, according to our naming rules, is iron oxide. But the thing is, they're two different compounds, two completely different compounds. So we can't just call them iron oxide. Well, what we do is we say the name, or we say the number of the cation. So here, take a look at this one. What's the cation? It's 2. So that one is called iron 2 oxide. Right? So what's this one? Well, this one is iron 3 oxide. And to figure it out, you have to look at what it's combined with. Okay? Let me show you an example. Let's say we've got, we'll do this one. We'll use AU3. All right? Let's say the formula is AUP. All right? So how do we know which gold it is? It could be gold 1 or gold 3. Well, we know that phosphorus is -3, right? Or phosphide, I should say, is -3. So there's only one of these, so this has to be +3 because that equals 0. So this one is gold 3 phosphide. Alright? Roman numerals, if you want to know what the Roman numerals are, it's 1, 2, 3, 4, 5, and 6. Oops, that's supposed to be a V. Okay, that's usually all we go up to. Alright? So here you can see the charges of the cations and anions. We can see here are the transition metals where we have more than one charge. Notice aluminum, zinc, and silver does not have more than one charge. And really there's no sense in memorizing them because you can always figure them out. Alright? let's talk about writing a formula. To write a formula, give the symbol of the cation, give the symbol of the anion, and then balance the charges and write superscripts. So let's do this iron 3 chloride here real quick. And until you get this down pat in your head, this is what I suggest. Iron 3, this is the ion for iron 3, so I would suggest writing that down. Chloride, here's the ion for chloride, so I would suggest writing that down. Now what you'll see in the video problem is we suggest a drop and swap. Okay, so the 3, just the 3, comes over here, tells me how many chlorides I have. The 1, there's a 1 there, just the 1 comes over here and tells me how many FEs I have. So I have FeCl3. Now, why does that work? Because Fe is positive 3 and Cl, right, I got 3 of them, is negative 1. Does that equal 0? Yes. Yes, it does. Okay. So that's my suggestion at first. Alright? So go watch the video problems and then I'll help you out. You need to come up with a good ending phrase. I'll work on it.